So in this video, I'm going over a co-op problem using a public goods model. So the situation would be two companies realized that they could use a shared infrastructure for their businesses, and so they pay developers and computer scientists together to develop the infrastructure that both companies can use. And I believe this will become more and more common, especially in the future and especially with blockchain. And so the co-op is behaving like a public goods. It's not non-rival and non-excludable. They can exclude other companies from coming in and using the infrastructure they've developed, but they're basically pooling their resources and purchasing something that neither company alone would be able to purchase without pooling their money. To think about this, we're going to have two different companies, each with their own demand for the infrastructure. And for this case, I'm going to use modules as an infrastructure. For example, companies need to train their new employees. For example, insurance companies might want to train their employees on how to process claims. So they need to know the details, they need to know how to interpret certain codes. And to do that kind of training, you could develop this online module where once the employee completes the online module, they know how to do something specific. And once that's developed, then you no longer have to pay trainers to come in person to train their employees. They can just use the infrastructure that's already set up online. So the quantity here is going to be the number of training modules that they're purchasing for this online infrastructure that they're using within their company. And we can see the demand curve for each of these firms is different. We have a demand curve for firm A that's P equals 40 minus 2Q. Q is, of course, number of modules, and P is the price you would pay for those modules. And we have a demand curve for firm B. And we might imagine a situation where it costs $50 to create one of these modules. So we have a marginal cost of $50, and at that price, neither firm can afford this. Now, I've kind of scaled down to make this problem easier, but of course, if you're building an online module, those are really expensive, so you probably need to multiply these by 1,000 or maybe 100,000 or something to get accurate numbers, but let's keep things simple so that the math is nice and easy. In any case, we've got a marginal cost of $50 for building a new module. Neither firm can afford it. The question is, can they come together and pool their resources to afford it? And to develop this, we need a collective demand. So if they come together in a co-op, we need a demand function for that co-op. And let me show you how that's done. Okay, so the co-op demand function, the way you're going to do it mathematically, first I'll show it to you mathematically, and then I'll come over here and show you graphically, and then we'll go over the intuition about why we do this. But we're going to have the same structure, so P equals, and we have an intercept, which is 20 for one firm, 40 for another, and we're going to add those together to get an intercept here of 60, which comes from adding the 40 and the 20, the two intercepts of the two firms' demand functions, and then minus, and we need a slope or a coefficient, and we're going to add the two firms' slopes, so minus 2.5 Q. And this is going to give us the total demand that firms together in the co-op are going to have for that particular product. So how do we think about drawing this? Let's use green here. So we know that for prices above $20, and 20, I came up with these prices with these intercepts by saying when price equals 0, what is firm A's quantity that they want? And that's going to be, for firm A, that's going to be 20, so plug 0 in there. 20 is the right number for this. So we know that for quantities above 20, the firm is no longer willing to pay at all for those. So we know that above 20, the only demand left is the demand that's coming from firm B. However, if we pick a random quantity in here, so we ask both companies, how much would you pay per module for 10 modules? Each of them has a particular answer. So firm B is going to say, this is how much I'm willing to pay according to my demand function, and we can actually figure out what that is by plugging 10 into the demand function. 20 minus 0.5 times 10, so 20 minus 5, so this is going to be 15. They'd say, we are willing to pay $15 per module for 10 modules. And for firm A, we ask them the same question, how much per module are you willing to pay for 10 modules? And we can get that by coming up to their demand function, and we plug in 10, so we have 40 minus 2 times 10, and so we get, that should be 20, so that should actually be that. 40 minus 2 times 10, that's 20. So firm B says we're willing to pay $20 per module for the 10 modules. So 15 plus 20, in total, the firms are willing to pay a price of $35. In total, we're willing to pay a price of $35 per module for 10 modules. So this is going to be 1 point on this demand curve. And we can check to make sure that when we plug 10 in here, we do get 35. So let's just check that. 60 minus 2.5 times 10, 60 minus 25, that is 35. So this demand function worked for this particular point. And we actually know the way this is going to work is we're going to start it with a slope up at 60, and we're going to go down until we reach the point where the only demand left is from firm B. Okay, so the total demand is represented by this curve with a kink when firm A exits that. So let's just highlight that. So now we have the total demand that both of these collective companies, when they come together in a co-op, have for the modules. And suddenly, even though they could not afford any modules with a price of $50 per module before, now we see that they're going to be able to afford to buy some of these training modules. So the next question is, how many training modules should the co-op buy for its members? And of course we can figure that out by finding at what point does marginal cost hit the demand curve. So how do we set that up? Solving for the optimal Q. We set that up by basically just saying, when do these two meet? And they meet when the marginal cost equals the demand. So we plug in 50 for our marginal cost. And we've got our demand curve over here. And of course we just do the algebra to solve for that. So the optimal optimal number of modules for the co-op to buy is going to be 4, which kind of looks like it matches up graphically if I've drawn this properly to scale. So 4 is the optimal number of modules, and that's Q star. And in which case we have to figure out what's our total bill to hire the people to develop these online modules, and how much should each of the two firms pay. So, and then what is the what's the surplus that these firms get from participating in the co-op? So the total bill is fairly simple. That's just going to be the number of modules they buy. They're buying 4 modules at a price of $50 each. So they have a $200 bill. And how do they divide that bill up to charge each of their co-op members an appropriate amount? And to figure that out, we're going to figure out what is the price per module that firm A will pay, and what is the price per module that firm B will pay. We'll find those out by plugging our optimal quantity into the demand function for those two firms. The price for firm A is determined on the demand curve at that 4. So it's going to be this price. So we plug the optimal quantity into the demand curve for firm A. And that gives us 40 minus 2 times 4, which is 40 minus 8, so $32. And that's per module. Let's do the same thing for firm B. Again, going to our demand curve and plugging in our optimal price. So we have an optimal price of 32 for firm A and an optimal price of 18 for firm B. So how much do we charge each of these firms to pay the $200 bill that we have for these developers to develop our modules? Well, that's just going to be the price they pay times the quantity. So times the optimal quantity that we've already decided on. So firm A is going to pay $128 of that bill. And of course, firm B will pay the rest, but it also should equal the $18 that they pay per product times the 4 products. So let's write that out. All right, so firm B is paying 18 times 4, $72 in total. Firm A pays 128, firm B pays 72. That adds up to 200, which is the total bill for the development of these modules. Now, let's see if we can find the surplus for each firm if we look at the graph. I'll do this in red. So firm A is going to pay $32, and that should match up with the optimal quantity at 4. So $32 is how much per module that firm A will choose. Here's firm A's demand curve, so we can recognize the surplus that firm A gets from participating in the co-op. And then for firm B, we see that firm B pays this amount per module, which is $18 per module, and their demand curve is given here. So for firm B, their surplus is going to be equal to... So both firms benefit from participating in this agreement. There's positive surplus for both. Now, one other case I just want to talk about a little bit. Let's imagine that over time the price of developing modules became cheaper and cheaper and cheaper. So let's say we ended up in a situation where the marginal cost was like $5. Well, one thing that might happen is the firms might separate and no longer do a co-op situation, but they've also realized that they can have a lot more modules if they pool their money and work together. So they like this co-op situation. Even though they could get by without collaborating, they benefit mutually from collaborating. In fact, even with this new situation, we will get a gain in surplus from collaboration as opposed to operating separately if this is the new marginal cost. The problem is if you go through the same steps that you did before to figure out the optimal quantity, I don't know what it'll be. It may be something like 38 modules might be the optimal quantity. But when you figure out how much each firm should pay, the only one of the two firms left is firm B. So if you do this just the way I laid out, you're going to get a situation where firm B pays the entire bill. And of course, firm A is not going to put up with that. They're going to be like, no, I would rather operate separately. I'm not... So firm B is the one who's upset about that. Firm B is paying for everything. Firm A is paying for nothing. Firm B is going to be like, no way, you can't have access if you don't contribute. In which case you need a different way of deciding how much each player pays. And this is also an alternative way of doing this, even if this is your situation. So one way of doing it is that you could actually add up the total surplus from the existence of the co-op, right? Like this triangle, technically you could use these numbers and figure out what is the area of this triangle, what is the area of this triangle, therefore what is the total surplus gained from firms participating in the co-op. You could then figure out what percentage of the gain from participating in the co-op belongs to each of these two players. and you could divide up the bill, the total bill, which in our case previously was $200. We don't know what it would be in this case. It'd probably be cheaper is my guess. But you could divide up the bill according to the surplus gained by each group. So whoever gained more surplus would pay a higher percentage of the bill. And of course, that already worked out here, but that is another way of dealing with the surplus. And so this situation will become more and more important as online infrastructure becomes a bigger part of what we do and as we get blockchains to facilitate better collaboration in the future.